time. So the quiz will never go more than 15 minutes, which means that when I say only spend 1 minute on each of them, 1 through 4, and only spend 4 minutes on problems 5 and 6, I really mean that. Because the whole idea of it is for you to kind of try to remember what it is we learned last time, and then move on and try to remember what else we learned. So that way you can kind of try to get your brain remembering the things we worked on last time. Okay. So today we're going to finish up 3.2 and start in on 3.3, get through most of that today, hopefully. You have your project lab part 2B due tonight by midnight. If you don't know how to do it, I am not going to waste more time on showing you how to do it. There are videos that I've done when I've explained it last class, right? And so just watch that again. Or if you got confused about it or weren't sure, everything that was in there. Also, Connect Math 3.1 is due tonight. 3.2 is due on Thursday. There's something I'm going to show you later on at the end of the quiz that will show you, that will help you with problems 14, 15, and 16 in here to do those a little bit easier. And then also, remember, every project spot from here on, you can turn it in. It's due today, tonight by midnight. You can turn it in late for full credit on Thursday. So it will be late, but you still get full credit for it. The point is that all sob stories should happen today, not Thursday. Today is when it's due. So sob stories, issues, problems, take care of those today. Today's the due date. And then as a backup, you can turn it in late for full credit on Thursday. Also next Tuesday, you have Connect Math 3.3 and 3.4 due. Yeah?
On Canvas it says it's due tomorrow, like the 19th.
Okay, I need to change that. It's due. So it's due today, but you can turn it in late on Thursday for full credit. Either way, you can turn it in late on Thursday for full credit.
Does it?
So
What if I turn it in tomorrow?
that's fine.
Okay.
Yeah, no problem. Yeah, so if you turn it tomorrow, that's okay. But again, the last chance to turn it in for full credit is on Thursday. Project Part 2B. When choosing class width, I showed you class width. Doesn't matter for this one. We're not actually doing class width. The point I wanted to make with this one was when you make your other category, because all you're doing with Part 2B is copying over your data and cleaning up 2B, right? Grouping those into categories so that you don't have more than 20 categories, and that you have, at least 2 or 3 things in each category. Probably 3 or more things in each category. And when you have your other, then your other shouldn't be, thank you, your other shouldn't be like 30% of your data in other, right? So it shouldn't be like, where do people want to go? Oh, Japan, and the Grand Canyon, and Hawaii, and then 40% other, right? It should be like grouped a little bit better, like make other tropical areas, or other Asia, or other South Africa, or something like that, right? Give them smaller groups so that you don't end up with a whole bunch of stuff in one big other category. Make sense? All right. Let me show you quickly where to find the video for the other part. So if you go to my YouTube channel, and you go to playlists, so let's see, go back. So when you subscribe to me, right, you've gotten my video, and you've hit, what's going on?
So we find all these things. Here,
So you
project
go to
math 40.
project, and then under project, all the parts are listed. 2B, you guys, the evening one, you're here. The night one, they ask more questions, I think, because it's 16 and a half minutes. But you can watch either one of those or both of them if you have still questions about how to do part 2B. If you have other questions that aren't answered in there, then email me those, and I'll try to cover them in the next class. But all the playlists, each playlist represents a lecture or project is kind of its own. So that one may end up getting bumped down the road a little bit, but it'll always be kind of in these first 2 rows for the most part, probably. Questions? No? Okay, good. Because it's much better if you guys go there for your questions, rather than us spending another 13 and a half minutes covering it again today. I'd rather you guys just watch that again. Because like half of you have finished it already, so it doesn't make sense to put everybody through that. All right. Let's take a look at 3.1. 3.1 was concepts of measures of center. In other words, averages, all the averages, values at the center of the data set. So the standard one is what we always think of when we think of average, the mean, arithmetic mean. That's when you add them all up and divide by how many there are. A little bit of notation. So this first thing, this capital sigma, that's the sum of a set of values. Right, when you add them all up, this means add them all up. X is the variable. And if you weren't here last class, these are on page 4. Bottom page 4, you should kind of be filling those in. X is a variable usually used to represent the individual data values. Right, so individual X, data values in X. N represents the number of data values in a sample. In other words, your sample size. And N is your sample size. That will come up over and over again all semester long. And then big N is the size of the population. And then we have X bar, right? That's pronounced X bar. Denotes the mean of a set of sample values. In other words, X bar is when you take all of your sample values, all your X's, and you add them up, you sum them, and you divide by how many there are. Divide by N. Mu, pronounced just like the Pokemon Mew, denotes the mean of all values in a population. So same thing. For mu, you add all your values in the population, divide by how many there are. You sum them. And it's this sort of, it's kind of like an M, so it's sort of like this. It can be that extreme, or it can be this extreme, or more like a U. Those are kind of the extremes of the writing the mu. All right. There are some advantages to the mean. Ria, go ahead and read.
Advantages. Sample means drawn from the same population tend to vary less than the other measures of center, and it takes every data value into account. The disadvantage is sensitive to every data value. One extreme value can affect it dramatically. It is not a resistant measure of center.
Right, remember that video we watched last class with Michael Jordan and how he was a real extreme outlier, so he pulled all the average salary that a UNC geography grad makes and made it like really big because he had this big giant signing bonus. Do you guys remember that, the video? Yeah. So that's the thing about means, is that one really big outlier like that can pull your mean over. It's not very resistant to outliers like that. Here's your quiz problem on the mean. This is what you should have done, right? Sum them all up, add them up, divide by N, divide by how many there are. Good? All right, moving on. I'm rounding off rules for that. They should have one more decimal place than in your original set of data. This one happened to come out with one decimal place anyways, but even if it wasn't, you should have rounded to one decimal place because your data has no decimal places, right? So then the mean should have one more decimal place than your data is in. Yeah?
For number 1, do we have to have the unit listed or?
Theoretically, yes. If it was a science class, I'd say yes, but since I'm kind of mathy, I'm going to be a wimp about it and not be that picky about it. Okay. Median. Corey, go ahead.
Median. The middle value and the original data values are arranged in order of increasing or decreasing magnitude. Is not affected by an extreme value, is a resistant measure of the center.
Right. So median is not affected by those extreme outliers. Yeah, so in other words, here's my median that UNC grads make. Doesn't matter whether Michael Jordan makes 100,000 or 100 million, the median stays the same. So that's why it's we say it's a very resistant measure of the center. It's very resistant to outliers. Remember how to find the median? You take your data, you put it all in order, and you find the one exactly in the center. You don't just take your data and take the one in the middle, because you have to put it in order first, otherwise it's not the one that you happen to have written down in the middle of things. It's the one that, when you arrange your data from smallest to largest, it's the ones numerically in the middle. If there's two that are tied for the middle, you average those two. Right, so when you have an even number, you'll have two in the middle instead of one. Does that make sense? Okay. So here is your quiz. The first one was odd, so there's only one in the middle. That's your median. Right, take your data, put them in order first. It's unfortunate that happened to be in the middle to start off with, but that's okay. Here's the second one. These two are tied for the middle, so you'll average those two. So then the median is 0.915. Occasionally it will have one more decimal place than your data is, if you have to average the two of them. Good so far? Anybody have questions? Anybody need 30 seconds with your neighbors? Mode. Anjali, go ahead.
Mode. The values that occur with the greatest frequency. Data set can have one, more than one, or no mode. Bimodal. Two data values occur with the same greatest frequency. Multimodal. More than two data values occur with the same greatest frequency, or no mode. No data value is repeated. Mode is the only measure of central tendency that can be used with
Nominal data categories. Right, you can have the mode of like colors, but you can't have the average of a bunch of colors. All right, so quiz problem 4. Mode is 110 because there's two of them and there's only one of all the rest of them. Bimodal, there are 327s and 355s, so those are tied for the most. So there are two modes, bimodal. Please note, if there was one more 55, then 55 would win and it'd be the mode by itself. But because they're exactly tied for the most, it's bimodal. This one down here, there are none that have more than the rest of them, so there's no mode. It can also be like this. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. That also has no mode, because none of them has any more than the other ones. But if I did this, now all of a sudden there are 4 modes. 4 of them would be tied for the most. Did you guys see that? So here, 4 modes, 1, 2, 3, 4. Here, no mode. All right, weighted means. So a lot of times we'll have data, some will have a higher frequency or a higher weight than others. Those weights can be decimal as well. They don't always have to be whole numbers. Last class they were all whole numbers, but your quiz today they were actually decimals. So what you do is you multiply every x value by its weight or by its frequency, add those up, and divide by the sum of the weights, or the sum of the frequencies. This is what we did last class with the GPAs and something else as well, the frequency table. So here's quiz problem number 5. Find the mean from this weighted distribution. So I would probably write these as decimals. You could do them as percents as well. You just have to adjust later to make them back into decimals off the percent. So I would probably do it like this. 80.7 has a weight of 12%, 12 cents. 64.7, that has a weight of 4 cents or 4%, right? 90.0, that has a weight of 15%, 0.15. So do you guys want just another 2 minutes to finish that up? Okay, so if you didn't do it now. I'll give you guys 2 minutes to work on that. Okay, so should you have something that looks like that? I think, yes? Are we all on board? Okay, so, and then, so here, you divide by the sum of the weights. So if you add up all the weights, they should equal 1 or 100%. So you divide by 1. Any number divided by 1 is just itself. Yeah, Angel.
So I know that you had said that you want one decimal space more.
Mm-hmm.
So should it be 77.3700?
No, one more is, my data has 1 decimal place, so this should have 1 more.
Okay, so it's not the numbers that you multiplied then? Because like you're.
Right. No, I'm looking at this. This is my data here.
Okay,
Yeah.
so then you don't worry about the weight at all? Because those are
Nope.
the two decimals.
Yeah, you don't worry about the weight at all.
Awesome, thanks.
Yeah. All right, round off again. So we're gonna talk a little bit about variation now and standard deviation. Yeah.
Doesn't weighted imply that the sum of W will always be 1?
No,
No?
because weighted, remember like the frequency is weighted? So then, if it's in a class, then yes, it should imply that the frequency should always be 1, because your grade should equal 100% of your grade. But if it's like grade point average, the sum of your units is not going to be 1.
Okay.
Yeah. So it depends. Yeah. So the weights could be whole numbers like we were last class, but if it's for a class, it really should be at 1 or 100% as the total.
Okay.
Yeah.
I think dividing by 1 just looks so strange, I thought it was wrong.
Yeah, no. Yeah. Yeah, anytime you're talking about percentages like this, right, then it should be 1. Does that kind of make sense? But if you look at the GPA problem, which is also a weighted mean, or like the frequency ones we did last class, and you have some on your homework like that, on your homework you'll have a problem that will be where you have to take the group frequency, find the midpoint for them, and then use those values times their weights, and then divide by the total weights to get your mean. It's exactly like the problem we did in class with the frequency, with the group frequency distribution. So you will have problems like that, and you have one on your homework for sure. It's like that. Okay. And that one's due tonight. Who's finished the homework for tonight? Okay, well that one's on there, and that's a tougher one, right? It's going to be a frequency distribution table. So it'll have a range of values. Here, I'll show you. Do you guys remember this one? So it'll be like this one, where you're given stuff like that. Right, and you have to find, here's your frequency, but your data is a range. So first you have to find the midpoints for your range, and then multiply each of the midpoints times the frequency, and then divide by the sum of the frequency, add those up and divide by the sum of the frequencies. So if you get stuck on that one, you should refer back to this problem we did in class. You did one just like this in class. And I think yours was actually this one. Right? So you should refer back to that one for that homework problem if you are struggling with that one. Okay. Back to here. So standard deviation and variation also same as the mean. You round to one more decimal place than your original data is in. Alyssa, Q, go ahead and read.
The standard deviation of a set of sample values denoted by S is a measure of how much data values deviate away from the mean.
Right, so the standard deviation is kind of on average, roughly, how far are each of your data values from the mean? This is the formula you will need to use to do it by hand. So you'll need to do it by hand with a dollar calculator, right? A calculator only has add, subtract, multiply, divide on it. So these are the steps you do it, and in the order you do them in. So first, you're going to take every x value and subtract the mean. Figure out how far each one is from the mean. That's your first step. Second step, you're going to divide, you're going to square. The third step, pink maybe? You're going to add them all up, sum them, that's the third step. That didn't go very well. Third step. The fourth step, okay, divide by n minus 1, because it's a sample. Remember, if it was a population, we divide by just n. Right, so remember before we found out how far every value is from the mean, and we squared them, and for a population standard deviation, we would average them, add them up, divide by how many there are. But for a sample, because our data is off a little bit, it's a sample, it's not the whole population, it's not perfect, we divide by n minus 1 instead of dividing by n. That makes it a little bit larger. And then the last step to find the standard deviation, the fifth step, is we square root it all. So this is the fifth step. Yeah?
If like that was on a test, you have to put it in that formula for you to see?
No, you just have to be able to find it.
Okay.
I don't care if you use the formula or if you just know the steps, as long as you understand the process of how to do it. So how how you guys did it is probably a little bit different. I mean, you did those steps, but you may not have written it with those symbols. As a reminder, you guys, as a reminder, the variance notation, S is your sample standard deviation, S squared is your sample variance. Sigma is your population standard deviation, and sigma squared is your population variance. So if it's for the whole population, it's going to be these Greek symbols, sigma, sigma squared. Because remember, how do you get from here to here? If you have the standard deviation and you want the variance, you just take this and you square it. If you have the variance and you want the standard deviation, you just take this and you square root it to get to that. So here's your quiz. Remember, I told you guys that the x bar is 3. Your sample mean is 3. So how far is 1 from 3? So the first step, you're going to do every, let's see what color I did that first step in. I did blue, purple, pink. So x minus x bar. How far is 1 from the mean? Negative, it's -2 below. 2 to 3, that's 1 below. 3 is right on. 4 is 1 above. 5 is 2 above. And then we're going to square all those. X minus x bar squared. Square them all. 4, 1, 0, 0, 1, 4. And then we're going to add them up. And then kind of divide by how many there are. We're going to divide by n minus 1. How many of them are there? 6, so 6 minus 1. So that will give us 10 over 5, or 2. And then the very last step is square rooting. S is equal to the square root of 2. I'm getting a lot of lost looks, so why don't you guys take a couple of minutes and do problem B if you haven't done it already. All right, so this one, the next one down. Again, you're going to find your x minus x bar. How far is 1 from 3? 2 below, 2 below, 2 below. 5 is 2 above. And then you're going to square all of those. Right? X minus x bar squared. And you're going to get 4. Next step is to sum them to add them up. And then you're going to divide by n minus 1, which in this case is 6, because there's 6 of them. And that will give you 24 over 5, 4.8. So then S is equal to square root of the last step, square root it, 4.8. That gives you your standard deviation S. Common sense, the last one. What's my standard deviation for that one?
0.
0. They're all 0 away from the mean. Good? And you kind of look at them. This one I think is 1.4, this one I think is 2.2, and this one is 0. You can kind of see how, you know, more or less they're all about, these ones are exactly 2 away from the mean, but because it's a sample, let's make it a little bit larger just in case. But in general, it's sort of a measure about how far they are typically from the mean. And then problem 7, we should go ahead and take a look at that, this one. So here, let's see. Do you guys want to take a, does anybody have a chance to finish this yet or not? Does anybody need a couple minutes to finish it? 7, problem 7? Because if you want, we can take a break now, a little bit early, and then people who want to finish it up can finish it before we go over it. Yes or no? Yes? Okay, take a break now. We'll finish this one up after the break. We'll go over it after the break.